Hello, and welcome to this Building the Main Session 3 as part of the buildingSMART International Summit, Marrakesh 2024. Thank you for joining. My name is Andre, and I will be your moderator today. Today's session is titled Leveraging openBIM Standards for Energy Retrofitting of Existing Buildings, a comprehensive openBIM workflow demonstration with IDS, IFC, BSDT, and BCF. The speakers for the session are Mirbek Bekbaliev, Technical Project Manager at buildingSMART Germany, David Ivey, Senior Design Technology Manager at HOK, Richard Kelly, Operations Director at buildingSMART International, and Jan Anders Jonsen, Owner at Informationsbybana AB. This session is scheduled to last 90 minutes, including time for questions at the end. The session is being recorded and will be made available in the replay section of the event as soon as possible. Before I hand over to the speakers, I would like to remind you that this is a hybrid event. For online attendees, your microphones will remain muted for the duration of the session. If you wish to make a comment or ask a question, please use the chat box in the control panel. For the attendees here in the room, please keep background noise to a minimum. And if you wish to make a comment or ask a question, please raise your hand and use a microphone. I would also like to bring to your attention that buildingSMART is committed to ensuring that participation in the development of standards is unrestricted and the process for their adoption is transparent. And standards that are developed do not favor any particular provider and are open, non-binding, and accessible to all. Please take note of our antitrust code of conduct. And now I would like to hand over to the speakers.
Good morning, everyone. I'm just wondering when it will start. Okay. We'll present you a short workflow, how openBIM standards and services are being used for energy retrofitting, as a building energy retrofitting. And I don't have to introduce myself, all right? We'll simply go through. So, yeah, I'm Mirbek, and let's go. We will go through some steps. You will be simply followed with us, and as you can see, we have just brought us. Oh, 1, 2, 3. Yeah, we have like a theater roles who will be taking on. And we have some models, we have IDS and BSDD, of course, BCF in our play. But before we start, Richard, would you like to?
Could I have the microphone?
Okay.
Just press the button there.
No, the handheld.
Yes, sir.
Oh, the
I
handheld.
want to
okay.
stand up so I can't see the screen.
All right.
Thank you. Oh, gosh. It's woken everybody up, including me. Yeah. Look, thank you, Mirbek, for creating this demonstration. We're going to take you through this. It is a demonstration, but there's an important reason that it's been created, and we all know about the challenges that we face in this industry and as a world, at large. In that we have this 39%, 40% of the greenhouse gases are being generated by the built asset industry. That's infrastructure and the places we live. And we also know that 8% of the existing stock is leaky. It's not very good in terms of its insulation. And in my country alone, there's over 19 million homes that were built prior to 1970, and they have not been built to the best standards, I can assure you that. So there is a challenge of what to do with the existing stock, as well as what we do in the future with all these new cities that are going to be built. So that's the scenario in which this demonstration has been created. Yeah.
So, thank you, Richard. We need to also capture information, and existing build stock is not so easy to digitize. Let's say, right? You have to face a reality. As you can see, reality is like you may have plans if it's an old house, but if it's old house, the pre-war times, let's say, you will not even have any plans. So you have to use methods, just model with the help of laser scanners, or simply take a ruler and go on site and check the reality, right? So you take pictures, you can compare everything. That's the most interesting thing, how to capture it later. Of course,
Yeah, so this is my house. I'm the client. So this is where my house is. It was built in the 1960s, and like all things from the 1960s, it's now old, including me. So it has these attributes in IFC. Merbek, what else do you want to say about these attributes?
Yeah, exactly. Existing build stock is important to do IFC georeferencing, and you need, of course, at least coordinates. You need to have an address. In order to do so, you have necessary attributes and necessary properties in IFC schema, and it's important. By the way, there is also public technical report on UCM that you can check if you don't know how to do IFC georeferencing in buildings. You can find it there, published long ago. So, yeah, and that's a reality.
Yeah, so, when I bought the house in the 1960s, no, I was born there, it was paper drawings, of course. So that's what we've got. We've got these paper drawings. We want to do some improvements to it. So where do we start? And, so engage an architect, and as a client, I've given them the specifications that, what I want is better insulation. I am concerned about the leakiness and the insulation in this home. I want to consume less energy. So in other words, I want better air tightness. The other thing is that I'm a bit concerned about the fire risk from the garage into the house. So I don't know what to do about it, but there's things there I want to get resolved. And also because I'm, ethically savvy, I recognize there are components in the house that are going to have to be replaced, but rather than throw them away, if possible, I'd like them to be reused. And this project, frankly, it's been giving me a headache. And I think the headache's from the stress of managing the project, but hey, it might be from something else.
So you as a client already explained your requirements. And of course, all that requirements should be captured, right? Like Richard mentioned, increasing of insulation, or let's say improving the energy efficiency of the building by increasing insulation, by increasing air tightness. Of course, it's also aesthetics, improving indoor air quality of the people who are living there. So it means habitat has a chance to have a better environment, lighter ceilings, right?
Sure.
As you can see, all that capture, that's what we captured from your requirements. Exactly. And
so if we're thinking about this in openBIM workflows, following the buildingSMART openBIM workflows, as a client, I've put forward my requirements. I'm not savvy enough to know what to do about it because, from the 1960s. But this story will now take us through how to go through the openBIM workflows and convert those requirements into something that I can live in, that I'm satisfied with. Would that be right, Merbek?
Yeah, absolutely. And as you can see, we want to use existing BSTD dictionaries so that you can profit from them. You have necessary information that you can map in your IFC models. But before you go there, sorry, we have go back a little. We have some more important information. We also need to capture the reality. Means you should capture the existing condition of building. If not just a building, in that case, we have a ceiling, right? We have to know what are the material behind the ceiling, what we have in general material, or like what kind of membranes we do have there, what is the material of timber ceiling, what's the lambda values, so like thermal conductivity values, and if we have also a chance to do building monitoring, but since it's a last time, usually building energy monitoring done within 1 year. We don't have such time, but we at least can do energy simulation. That's a more interesting case here. We do two cases, pre-retrofit or like pre-improvement and post-improvement cases.
So you're my energy consultant I've hired, is that right?
Yeah, actually,
Hey,
I'm an energy
hey.
consultant in
Yeah.
that case. So we
have
said we
expertise.
will try to go through some items, and of course we know that what issues, building issues, we will potentially face, like air leakages, cracks, openings, some maybe structural failure, maybe hazardous materials, especially mold. It's easy behind the ceiling.
So that could be my headaches.
Yeah, that's maybe a reason for your headaches.
Okay.
Exactly. So now we have we went through we conducted blow test. We conducted thermal imaging of the whole building envelope, and of course, how it ended up in IFC. As you can see, there is a very famous video what openBIM does for you, and it's actually this video is available. You can find it on nets and just check it, and you will see it. And there is an important thing. All that standards and services are present here. As you can see, just as a school, as IFC building, we have a housekeeper, let's say. Housekeeper plays a role of facility manager or asset manager. In that case, you have a BCF for communications, for tasks, for documentation. Today, we will also talk about documentation, because documentation of existing stock is most important than we're not planning here exactly, but we document. In that case, we'll have to use BSD, and we have to use requirements. And in that case, ideas.
So Merbek, I read something because I'm, as a client, I like to read around. Just go back a bit. So the requirements I gave you, are you now converting those into computer interpretable information using the IDS? Is that the intention here?
Yes,
Right,
absolutely. Okay. That's absolutely. And of course, a basis for most of the requirements are coming from BSD. So we don't reinvent the wheel. We don't take some custom properties from somewhere else, but we go to BSD, we check if the thermal conductivity or the infiltration or other properties are present, are available. If yes, they can use it, and they can map it with existing IFC schema and apply it onto our objects. So that's workflow, classical workflow, how it looks like. We start with capturing information. We start with modeling later on, and improving the building with the help of BSD. And then, of course, we do check. We communicate with BCF. We give feedback. We document and give tasks. So today,
can we just go back to, because again, as a client, I'm interested in what's going on, even though I'm not very competent. Can we just go back to the flow, the workflow? So just to summarize, I've given you these requirements up here.
Yes.
Yeah. And actually, you're telling me that I've got to create the IDS. Well, I can probably do that. There's a really good web page now on the buildingSMART website. I found it the other day, and I reckon I could do that now. So the IDS is then sent to the modeler. The modeler verifies the capability of the software. And how does he do that? Is that some form of verification?
Yeah, it's IFC validation tools, or there is also capabilities, of course, of software, if that software is able to export IFC in general. So you have a chance to go to IFC repository, where there is a list of softwares which implemented IFC standard, any schema starting from IFC 2x3 until IFC 4.3.
Okay, and then it goes through this data enrichment.
And of course, not everyone supporting BSTD, but it's already some that implemented BSTD API, so you can directly profit from them, and you can even in some cases import ideas. But we can just through. That's how you do it in general. Actually, we already explained to you, right? We capture information, we deliver information. That's like a ping pong game, and we don't in between. We also communicate. I think we have to mention that in between you verify, you provide proof, And proof we can also provide with the help of BCF. That's how we use all that spectrum of standards and services for buildingSMART. So now I will go through details that we already mentioned. Richard, you mentioned that you want to have a hazardous material mentioned in BSTD, of course, or in your ideas. We went through BSTD. Is there any hazardous materials? Yeah, we got lucky. There was a dictionary that mentioned hazardous materials. We went through volatile organic compound tiles. If there is a chance to do so, we found one also from A team. They have VOC related classes and properties. We thought we need to check if we have all this or European or German version of fire safety rating, and of course fire rating, it's also a property in the IFC. That's a really important thing. And we don't reinvent the wheel. Of course, we want to improve the building. So that's a BSTD. In meanwhile, it's as the address search BSTD building. You can directly use it. You can add any word. It will find you related class, related property that you may, starting from hazardous materials, right? Like I said. And how it looks like as a proof, there are screenshots, as you can see, hazardous material with all description, or on the right side, volatile, VOC. And of course, dictionaries always can end in ideas in that way. So we have a model. That model should have a property called hazardous material. Within PSET, IFC material, and with the value HP4, it's a predefined value, irritant. Why it's irritant? We have I think Richard, you realize that you have roof insulation being glass wool, and the glass wool is irritant material, so it's potentially can cause, let's say, health damages. I will call it cancer. It's so you have that kind of materials that you should be aware of, and of course, that information will land in ideas. That's left side.
We use the recently published decommissioning reuse publication on the.
Absolutely, that's what we use exactly. We found it recently. It was recently published, decommissioning and reuse, and that dictionary.
They applied for the award.
Yeah, I know. That's exactly. But the thing is, dictionary is open. buildingSMART data dictionary. You can find everything what is published. Of course, you should be aware if it's an active or it's in a preview stage, but still you can use everything that, since it's open standard and open service. So that's how it looks like. On the left side, you see the human readable, let's say, the fire pressure. You also wanted to have fire safety for our client was very important, and we want to have a fire safety captured in idea. So you have fire safety ratings captured in ideas for all elements like the walls and ceilings and so on. We also want to have a fire extinguisher to be installed, or sensors being exchanged. We have a sensors as well, IFC sensor. There are different types of sensors, like a fire sensor, CO2 sensor, CO sensor, and so on. And as you can see on the right side, machine will understand that. It's a machine readable. As far as I remember, we, the BIM coordinator or BIM manager, also consulted Richard not to use building element proxy, and required that every engineer and architect and whoever will be doing the model should properly map IFC, the whole schema. I mean, related elements to be properly made by IFC schema. And of course, we don't want to have, in ideas, you have a chance to prohibit any element. So it's a chance that not many know, but it's a chance to show what is not allowed and what you will find in IFC building. Luckily, this is just a QC control as a quality assurance of the whole thing. Before you send, and as an architect, as an engineer, you should run the quality control by yourself before sending to as an architect to a structural engineer or MEP engineer. You should check your building by yourself first. And there are many tools, there are many ideas, options that you can simply upload and run. And of course, we have also a role of further expert like LCA expert and Jan Anders.
Yeah, and as an LCA consultant in this way, I need to know something from the model, and to do an LCA calculation is more or less the same as do a cost calculation, and you just enter the events of the like, and when you do a life cycle calculation, then you have events with things that happens during the life cycle. And what do I need to do a generic, to talk about the average global warming potential? Then I connect to a generic database of information, and then I need from the model just, in fact, two things. I need the measurement, the area or the volume or something else, and I need the classification, a good classification that points me to that is what I need, and the classification connects me to a LCA database, a generic LCA database. And if I know what materials we shall put in, then I use specific data using the article identification, and that takes me to the EPD, and the EPD gives me the information about the loads. Environmental product declaration.
Okay.
And that's will be a standard for, in fact, nearly everything in the future. And we got in Europe, yeah. And then I can do my calculation. So
Okay.
I don't need that much, in fact.
In fact, we actually energy consultant and LC expert working in tandem. So it means we start with energy simulation, because before you do energy simulation, you have to have a bill of quantity, let's say, like quantities that you need to run. As soon as we know the energy demand of the building or structure or whatever building, then LCA consultant takes over and runs what we have as a global warming potential in that case. So we captured one information in the building that we want to provide to our client, and that's a number, let's say, within the building that we captured, and that number will definitely tell later on, maybe especially for incentives. There are many new incentives, especially for loan, that if you can, and even in some countries, it's mandatory to deliver that information now, especially within the European Union.
Okay, so as an environmentally aware client, I'm quite excited to hear that all this information is available, and that there's a process that you're going through to be able to turn my requirements, my loose requirements, into reality. So we now have the contractor on board, I think.
Yeah. So the energy consultant gave all necessary information, directions to contractor. Then
Yeah. So normally we come in and we just start swinging hammers and trashing everything, getting ready. But we know from talking with the client that hired us that they're looking to reuse the wood panel ceilings up here in some form, And we've also gotten a heads up from our consultants that there may well be hazardous materials, so we're a little prepared for that. So as opposed to just coming in and wrecking the place, we're disassembling the ceiling, we're disassembling the door. So we've taken a peek inside here, and we've seen that indeed there is mold in the ceiling, mold in the insulation. So we've taken steps to remediate that. We've removed all the mold. We came in with the proper equipment because of the heads up that we had before. That's probably why Richard was having headaches. So we've taken all that out, and then we've just stacked everything and taken all the reclaimed wood that we can, both from the supports for the ceiling and the ceiling itself, to be reused. And then, these were out of order a little bit, but we like you said, we came in with the safety equipment. We protected all of our workers. We kept all the insulation, bagged it up, got it out, and kept the whole house clean while we were doing it. And you can see some of the bags of insulation that we've got after we pulled apart the ceiling. And then we took, like I said, we took the remediated boards. We turned them into, you want to hit the next slide? Yeah. Oh, sorry, this is the, no. Yeah. This is the architect's rendering of the finished ceiling. So we're going from some kind of a darkish board ceiling to a light white gypsum board ceiling. So you can see there we've put in all new insulation, clean, mold-free, gyp wall, painted white, all great, all done. We also replaced the door to the garage, which was an F30 door with an F90 door that's a insulated metal panel door. So he's got a nice cozy place to hang when he's not when he's not gardening, right? So we built him a nice planter to go back in the garden. This is a potting, it's a potting shed, let's call it, or potting planter. All made from the recycled wood that we got from the ceiling.
One interesting point here, if you check behind, we have material that we had to consider a cause for mold. In airtightness itself, it's good, but if it's not properly done, it will potentially cause. So the new membrane should be open diffused. So it's like it should release humidity, but not at the same time be airtight. So it's intelligent membranes. And it's of course by time, if you have a PE sheet, in that case, it will not dry out with the time in winter. So that was a main reason that you have this.
So make airtight, but ventilate right.
Absolutely.
Yeah. Okay.
That's exactly the point. And of course, as you can see, you have to think about cause of the VOC compound that you definitely found within the structure. So you will not be able to reclaim everything. I guess we also stored some timber components away, and of course that's what we wanted to capture within existing. We have existing building. We have this ideas, and there is a property that we want to say this is hazardous materials. That's why we want to have it. And I guess even for new building, I mean the post-retrofit insulation, we kept that property for new material. Every, I guess, a 25 or 50 years guarantee. After 50 years, so we have this material to be sold at the deponey. I don't know how to call it, like a site where it will be simply dumped. And of course, it should be dumped in a proper way, like already our contractor mentioned. And they did a great job. Okay, let me go through the details that we now run and test. We have a BIM and BAM report that was published 2 or 3 years ago. It contains exchange models for how to do a building energy simulation of all buildings. Yes, it is.
just on the microphone, folks, because we are recording.
Is it published on the use case basis with the website? Because this looks like this is also a PDF, but it's also
Yes, we have several options. We started with Jeffrey Willett and Paul Wooders. We thought we will publish ideas, which is you will see today. It's a draft ideas, but we based on the technical reports. Let's say exchange models. We don't reinvent wheel. We simply want to bring it not as a PDF, as an idea, so people could use it to run simulations properly. And that's the main reason we keeping a little bit longer, but we have several use cases that was mentioned in a technical report, and we published 2 of them already. And one of them is daylight analysis. Sorry?
Just this is on and off. But that report, it is published on the buildingSMART website in the standards library. And it's actually, I don't know whether anybody saw it, but David Delgado sent me a podcast a couple of weeks ago.
Oh, yeah.
I think it's 12 minutes long or something like that. I started listening to it, and it was a couple of American people talking about that report. Actually, they weren't real. It was all AI, but yeah, it was a nice, succinct summary of that particular report.
Yeah, this. I think we can even use that one to when we will publish that ideas. We can give you an expression.
I'm changing the subject slightly, but that podcast fooled me completely. And I played it to my 23-year-old son, and within 10 seconds he said, "Well, they're not real." So I'm just not tuned in.
All right. So as you can see, use case management we've already mentioned. We wanted to check if already one use case, retrofitting of timber. Or a timber roof or ceiling was there. Unfortunately not, so we simply took a chance. We will do that next time. And we found some related use cases we can profit from. Those are requirements that we actually need in BIM and BAM. It means we need to provide the IFC models that way that even lazy engineer simply can import IFC model, run button or push a button, and it will run a simulation. Of course, there will be some additional work, but minimum work, so that the engineer doesn't have to do all that mapping stuff twice, or georeferencing, giving information what materials is being stored within the layers and so on. So all kind of information you can directly give. And as you can see here, just one example. Condition, air leakages, air tightness, you can also capture in the building. As you can see, you can also provide information, vital information like thermal conductivity, also in ideas. And it's a part of a schema. It's a very important property. Since we wanted to have incentives apply for certificate, I guess in the future, Richard will apply for some kind of green building certifications or incentive, make it get some credits. For that reason, you may have certification. You may have some requirements, or at least to keep an eye on them. Let's say here we have a passive house requirements, and it says you have to have external. In that case, we have a roof, 0.15 kilowatt per hour, watt per meter square per Kelvin. We have that U values already indicated, so we should meet that requirement. And of course, we have to keep an eye on other requirements. So this is a process map of BIM and BAM that time, and it shows that we already have ideas also that time as well. We started with capturing information from the client, capturing information from energy requirements, and we try to work in collaboration with other disciplines, especially with architects. Yeah, ready? Okay, let's go. When we have now possibility to use mapping tools, if we have some kind of new items that was not available within the buildings at time, but Richard wanted to have new sensors, we want to have exchange, put additional fire extinguishers. So we can have a federated model, we can add them on top. And plus, as you can see, we map them properly. It's an IFC sensor, it's a fire sensor. and I can export that with the help of BSTD with necessary properties. And we communicate with BitCF. Here, as you can see, a BitCF as an AND is being replaced. And of course, we add properties with the help of new APIs. There are two types, the two examples. One is from Digibase from Netherlands. It's also good one. Other good one from Japan, it's OpenAC. It's not an advisement, but it's just giving you advice that there are already APIs that you can use BSTD. So you can not only use BSTD for that purpose, but you map your content through BSTD, through APIs, all necessary components into your model. And of course, there is also BSTD and BIM authoring tools like Revit, AAC also supports Civil 3D, I guess, and of course SketchUp from Trimble. There are really many examples. So now it's just a screenshot, and we will go. I guess we will switch into the live demonstration. We had to capture Richard's information twice. Why twice? We have case pre-retrofit, like before we started improvement, like existing case, and we have retrofitted case or like improved case, and those there we have delta. Of course, we have also models before and after, as you can see. Just to see, we did some simulation. The energy consultant did simulation. I used Design PH. It's just a plugin that enables from SketchUp into SketchUp. You can simply import IFC. It has a plugin that enables you to run some script, and it will land up in some calculation tools that I'm using for passive house calculations. And as you can see, there's an existing building. Richard, you're paying a lot for your bills for heating, but as you can see, you paid one. So it means your energy demand for heating 197, which is example. Passive house standard requires only 15. So you have 10 times paying more money for your energy bills.
See, this is very interesting information to me, because I've had an argument with my wife for the last 20 years in this house that, you know, we should actually spend some money on improving the air tightness and the insulation. And she said, no, that's just, you know, you'll never get that money back in the energy that you'll save. And we've never been able to resolve this argument. So now you're giving me data that I can actually have a proper conversation with my wife about.
Yeah, and this data is stored in IFC model. I mean, not the energy data, but it gives you a chance to use it as a basis for your energy simulation.
Of course, more important than that, it means I'll probably win the argument.
Yeah, absolutely. You have a proof now. You see there is an energy, otherwise there's an energy pass, and it shows where you're currently standing. And with the help of our LCA, we have also...
Did you make two calculations? One of the existing building and then one.
Yes, and this is existing building. And
this is existing. Okay.
Yeah, and now, as you can see, Richard, after improving your ceiling, we improved the not ceiling, the roof insulation. We increased the insulation. We went from 100 millimeter to 240 millimeters. We plus applied intelligent air tightness barrier, continuous. Contractor was really helpful. Proved later on with a crew that we don't have any leakages anywhere, and we run the blowout test again. We run the simulation calculation, and we end up with 163. So you saved already one passive house, almost like demand of passive house buildings energy load. So it means 20 kilowatts per hour per meter square per annum. It's a lot. I mean, already. Of course, it means at the next argument for your wife, for your spouse, would be not only improving the roof and air tightness of ceiling. It will be next step to do cascade in retrofitting, which means improving the windows, improving the doors, exchanging or adding additional insulation on basement, outer walls and so on. So it will end up in you can reduce your energy loads. This is important. And of course, we always will be able to prove that part, and we are proving now how it looks like the reality. You're ready, right? Do you have any questions before we start with live demonstration? Anything that was not unclear? Feel free to ask. We have, I guess, 30 minutes. Yeah.
Will the fire extinguishers be heavy enough to prop open that new fire door?
The fire extinguisher, by the way, is placed in a garage.
Okay.
So it means aesthetics. That was a wish of your wife.
Of course.
Yeah, it should be somewhere.
That was a joke as well.
Did you slept in Richard's study room the whole week that you were doing this? In real?
Let's say so. So it was, but of course, during the construction site, you're not living there. So, but in general, it's possible. By the way, if you're not aware, the IFC schema has occupant-related information, like properties. If you rent your house, you can also add that into your model. And you can add additional information. What type is a building? What type? By the way, we also captured that one. Before you go through, let's go check the IDS, how it looks like. That's what I want to say. Let me open the IDS that we created one. I will open simply human readable. I think it's easier for everyone to understand what otherwise it will be simply XML schema. So that's how it looks like. Simple IDS. We're all there, and we start from top to down what we exactly wanted to have from Richard, right? Richard said, we want to have a building. As you can see, there is a building there located on that side. We have coordinates, strict coordinates, what we need to follow. We have a land registration number. We have a building ID, which is a permitting ID. We want to prove that we also have a building name properly named. We have some attributes, we have some properties. The address is here. As you can see, we have fire protection class as a building. It's one according to German regulations. It's a residential building. And we have, if it's a type of the building, as you have residential, you can capture that. By the way, it's not custom property. They are all standard properties of IFC schema. And properties, actually, they're flexible. The difference between classes and properties, the classes will be difficult to map. You need to know what is the class in IFC 2x3, if it's the same with IFC 4. If not, then you have to change and add additional type, telling you, or like facet in that case here, we have a door for whatever. So you can adjust everything according to every standard, like a standard schema. And as you can see, we go down a little bit. So the year of construction, building was constructed in 1965. The latest, as you can see, it's existing building. We have already captured latest renovation. I don't know what was renovated at the time, but with 2021 was some changes made. So we captured at least that was some information that we provided in the IFC model. And LCA expert, as you can see, IFC building, here you are, the property, the building should have a property called global warming potential, fossil fuels, under the PSET global warming potential. And we will give you the number, and later on you will be able to see it. Of course, if we go down, scroll down, there are many other requirements that we wanted to capture. Not everything. Today's demonstration is just a demonstration. It's not that we will show you ideal model with everything perfect. There will be some errors. There will be some issues that you can check. If you need, we can also create one BCF together. That will be, I guess, fun for you. So anything that you can see. If you have an interest, we will share later on these PDFs, and you can just scroll down, maybe even use, if you want to have that ideas as really human readable, that will be also available along with presentation. Okay, then now I will change to the models. Let's go further before to our retrofit model. We have a model, and if you remember, we have, by the way, most important, you wanted to have all manufacturer information of all components, right? We're dealing with existing buildings, so you have existing information of let's say components, building components, and in that case, just an example, we have windows, and this is an entrance door, and the IFC schema provides us all that property sets that we need, and as you can see, P set manufacturer type information. Just go there. As you can see, it's a Schuko. Okay, it's a classical one in Germany. And we have a fire rating property, door common, and we have a fire rating F90 there with, is it external door? Yes, it is. Is it, has the thermal transmitters? As you can see, 0.75, which meets passive house standard. You already have one door, but only one door that meets at least the one. So you don't have to change that door. Other ones as well. But other ones, you will have the windows and doors should be exchanged. So what does it mean? If I want to create now BCF as a recommendation for you, I will create you a recommendation to the client from the energy consultant, giving a recommendation as a basis using BCF. That will be not a task, but information to the client. Okay, we can run simple check, like I'd say, we can run any kind of code conduct, like a code compliance or building code compliance checking. We can run that one. Definitely, it will not meet requirements because it 1965 was completely different regulations, I guess, than now. So those are files, as you can see, ideas that we created, and we will run the pre-retrofitting case. We have our building site, building story, and as you can see, we don't want to have like client required no proxy elements. If we will have any proxy element, it will highlight, right? We have, of course, some requirements. If I run this test live, as you can see, without see any issues directly, or like the topics, potential topics being identified. As you can see, we start with building element proxies. Do we meet that requirement? Yes, because we don't have any. We mapped every component at times. It was long ago with a proper class. Of course, if we don't match the requirement, let's go to garage door. We have garage entrance door that you wanted to have as I need to open it first. Give me a second. Garage entrance door. Yeah. You remember it was a timber one. We have some properties related to that. Like, make it a little bigger so it will be. Here you are. We have F30 door. It's leaky. It has thermal transmittance as value too. It's bad one. So you can simply throw it. I guess contractor did it in fact. So we have simple case where you can compare two cases before and after.
Which property is not there? What's the result of the check? Which property doesn't say?
So there might be values not, for example, we miss manufacturer value. It's not there. We don't have fire resistance rating. We don't have serial number because that door was existing since 1965 and no one tried to capture the information for that. So, and you don't have any specs anymore. So all that information, if it's not meeting, and of course, you should also check about requirements. So those, and we also have one interesting case like a garage door, the same way. it's already there, but there are many other issues that we couldn't meet. It means unknown oral widths. We have we don't have we have some unknown attribute for operation type. So it was many. We had many issues in that case, trying to find out what is currently not meeting, what should we improve. If we go further, we don't have fire extinguisher there. As you can see, directly shows. Sorry, we don't have fire extinguisher. We didn't have that one. And let's go to one case when we have the first important thing. We captured, there was a name convention for all spaces. We captured, by the way, that precisely, and we don't have any issues with them. We have all rooms of the name properly named in IFC space. Why IFC space important, by the way, for energy simulation? There is especially one case, second space space boundaries. You will be able to know what is the building materials are there, what are the next layers, what the adjacent place has windows and other places. Andre, is it something that I have to be worried about? Oh, okay. Oh, okay, sorry. So we tested it. It looks like good. Let's go to second case. By the way, we have now BCF as well to show. Post retrofitting. That's how it looked like. We have different structure, roof structure. We have standing seam roof, and we have insulation, additional insulation. If we will check, we have to run the same checks. Okay, and we will add now second case, like pre-retrofit ideas. Sorry, post-retrofit ideas in that case. And run this installation. We don't have some cases like garage door. Let's check the same garage door now. There might be some other issues, but we meet a requirement of our client, and now it's F90. But I explicitly left one thing there, thermal transmittance. It was missed, doesn't meet the requirement. So this is an issue. Why it's important? Now I can create a topic. How you create, if you're not familiar how to create BCF. This is a feedback to let's say, I will call it missing U value or wrong U value of garage door. So you create a issue, and of course you can please check U value. And you can leave some description. If you need, you can. By the way, there was a previous session of building domain, fire safety, equipment analysis. They also wanted to communicate how you provide documentation within BCF. I think it's also a message to BCF working group, buildingSMART. You can attach certificates either as a screenshot or as a link, just www. You store it in a common data environment in CD somewhere, and it's available. So you can simply open it, you provide the link. So it means, sorry? Actually, I do it in the description because we don't have other field. It will be additional, maybe request for new update of BCF that we have additional type where it can provide the links and provide documents as PDF, or at least as PDF and some other. So it's a good basis for improvement of BCF as to the next level. I guess it's even many others realize that the BCF is powerful tool, especially when you exchange document really dynamic process, dynamic results. And dynamic results means it's open, as you can see. It's not an error. It is error. Okay, is it open? A week, 2 weeks later, Richard, as a client, will ask, did I correct that? So you can simply even track if you have some tool like a facility management tool, asset management tool, maybe there's directly change management tools. You can directly check if my client, not client in that case, my contractor, the engineers did their job properly. If it's still open, I can track that information. I think it's the most important aspect here. And we share the certificates. I think with this point, we can wrap up and say how you, by the way, I forgot to show you.
Just on the, no, sorry to interrupt. Stepping out to demonstration for a moment, I've had conversations with a few people just recently. They're saying to me that this BCF standard, we know what it is, but they're saying they're using it extensively in their workplace, and it's something that actually, there's like a buildingSMART PT, we should be promoting more somehow. The benefits of it. So it is very good, and I'd like to learn more about it certainly. But yeah, thanks for that little explanation.
Yeah, that's absolutely. And as you can see, just if we use IFC models proper way, I'm a laser engineer, like I said, simply import the IFC model and it will be there. And I don't have to run another simulation or recreate the model in the native format. It will save me time. Of course, it saves time for contractor, saves time for engineer and all other who is involved. And of course, the single source to truth will be there. That you can see, we have like I say, this is just an example. That's a previous case, but we have already Buildin that it was simply based on IFC 2x3 model. You can use it, the old one, because you need to. By the way, you need to know the exchange requirements or capabilities. You remember we had the workflow. Know your capability for your software. Why it's important. Here, I want to explicitly show you why it's important. This is a building was modeled, right? But the case is here that we don't have floors. Why? Because they were designed in such a way that we have layers, we have insulation layer, we have flooring, like IFC covering, predefined type flooring, and unfortunately the software, not everyone is capable of reading. So it means in my use case for daylight analysis, I need IFC slab, IFC roof, and not IFC covering, predefined roofing, and some other cases. So this is important to know. And this is a case when I simply can enter the building, run simulation, and provide certificates. As you can see, you can also run simulation that is already there. So calculation results, again, outputs are there. You can give directly simulation, and as you can see, visualization and so on. So it's just IFC import, export, giving feedback to the client. You can use it BCF for that purpose. So at this as well. No, they don't. I think, but they will. Someone. Yeah. So it's just absolutely. Okay. Then at this point, we wrap up and collect your questions, or if we have any online questions. Not yet. Okay.
How many online? Yeah, well done, Babek. Your brain amazes me.
All right. Well done. No, well done, everyone. You. So thank you for players. I mean, for joining this workflow. Thank you for attending this online as well. I think to run such a play, you always have to improvise. We did really good improvisation. And of course, we need to have a precise models that later on you can prove. So it's a long-standing process. It's coming and going. This is like a real project. If you run a real project, it will be ping pong game. And this game, you should know that openBIM standards building smart standards and services at the whole functions together, and you can, as you can see, they're interconnected to each other. That's like my last statement. Thank you.
So I'll ask a question. Was that useful? I mean, Mirbeck is the inspiration, the creator of this. Was that useful? And if it is useful, would it be worth us refining it and turning it into a more professional package that we could roll out and perhaps do as a video and things like that? Lex, you're nodding, so that sounds good. Yeah, Luke, yeah. I think it sounds like you're onto something there, Mirbeck. I think this is something that needs. We ought to put some effort and maybe some resources into making more succinct. I think is like a video or something like that. Yeah. Oh, very good. Okay. Any questions from the audience? Yeah. Hi, Aaron.
Yeah, I have one question about the LCA, the visor. Are you still using the BIM models? Are you using only the data in that? Because I can imagine a lot of advisors don't use the models. But
I need the model to get the quantities,
yeah.
and I need the model to give me the information about the identification or the classification, depending on if I use generic data or specific data.
Okay, yeah, because as I see now, there are a lot of advisors that don't know how to use a model, so they use the what data, but
Yeah, but
if I deliver an IFC, they say,
no, but it works quite good if you just get up the requirements and say, I need this from the model. Most of the models that are circulating out have bad quantities, and they have bad marking of classification. So, but if you drive your demands in the right way, then it's very easy. Now, I use it every time.
okay. And do you have a calculation program?
I have my own.
Visualize.
I built my own.
Okay, based on IFC. Yeah.
Based on the IFC and based on the Swedish calculation, cost calculation programs and so on. So you get the sources from the best way. If you are in the early stage, then the model is the best. If you gone to the cost calculation stage, then I use the output from the cost calculation, because then I have the methods more. And when I get into as built stage, then I use the model again, and then I have most of the information I need about identification of materials.
You also did a calculation of the energy use of the building, probably the energy.
Yes, absolutely.
The building energy model. Or
I had to.
Did you use the space? All this, because in your model there were no space objects you just mentioned. Or?
I do.
Oh, you did. But the IDS check said no space objects.
Really? Strange. Show space.
There maybe only a check. Okay.
Give me a go. I can show you spaces. Like here you are.
Okay.
Here's a space. Space name is want estima, like it was required, and we have space boundaries.
Yeah. Second level.
Boundary, yeah, second level, and here here you are. Space common. Category, floor coverings, and other related. It's
not the capacity of the space or the
But this space, I mean, occupant number, you mean? That was not required. That's why I didn't enter.
Okay,
The occupant number was required. Actually, in general, you should enter for whole building, like because occupant number of spaces, like, is it habitable space? Yeah, yes, no. Is it climatisiert? Is it I forgot starting in English. If it's
German.
conditioned,
Yeah.
it's conditioned,
Yeah.
not conditioned, heated, not heated. So it means that information you can capture in IFC.
And then you took it into SketchUp, and then you pushed it to that tool that you mentioned,
Yeah,
for
absolutely.
example.
Yeah,
And then
for
they
example.
were using the space objects to calculate the
As well. Yeah.
energy use, or did they use the
Actually, that's
surface?
even IC space is even IC space is enough to export IC spaces. Run
It's
the
enough.
whole thing. It's in
Yeah,
some
that's,
cases.
that's why I'm
absolutely.
asking all
Yeah,
that
absolutely.
also. Yeah.
You don't have to
So
do
you-
the whole thing. In other calculations like JBXML, they're also creating spaces and exporting it. So it's a similar case. But why it's important spaces? Because the spaces in passive house, the outer how do you call it, outer boundary in the building envelope is plays more major as a most important role rather than internal. That's why of course you need also have external envelope, and in that case we had only one external envelope for roof. That what was relevant for us. By the way, if it's a postscriptum, I think you can see that all that information, like I already mentioned, you can also put onto your model. Just attach a model like a fireplace. We have as a fireplace. You go to BSTD. There is a requirement in the IDES. I can show you later on, or you'll get an IDES by demand. You can attach that as a, let's say, IC burner with predefined tab. There is also specific property, and of course you can put the values, like is it gas heated, like with a gas or the coil or with a wood. So in that case we had the chance to do that in BSTD, was simply directly applying all that information through BSTD. Just go and attach, and in IFC you can directly find related IFC burner, right? Sorry. And then you can just go to the object definitions and find the related class. As a product, elements, I think it was element. Whew. Okay, that's how it looks like. And you go and you apply. I think we was a time out, right? 10 minutes more. I think if we don't have another questions, or do we have any questions online?
Are you in your reaction?
Yeah. We have a quite big factory that does the whole day scanning existing building, prefabricated new elements for existing building.
As well.
And we find out that you don't transfer that much data, for example, from a point cloud to, let's say, a new based zero model, existing model, because the existing building is curved. So every time you make a new model, you get only a loss of data or less accurate.
Yeah.
So we're more in cutting out the point clouds on the part we need and gets data on the point cloud, but not model it again. So that's my suggestion. Watch out to remodel something, because it's always less accurate than the real starting point. For example, you started with, we're going to make a simulation of energy. You have the best simulation, is the energy bill of that house. So we are always in a state that we have to guidance this kind of customers, that we promise them what the new energy bill is. So we are more in the way that we pick up the current energy bill and make a solution that we promise to get on a better energy bill afterwards.
Absolutely, it's an interesting point. I forgot to mention, but at least in previous energy pass regulations that you should create, you can use two ways. You don't have to do any energy simulation, any building modeling, anything. Just take 1 year, the whole bills, submit it to this platform, and it will calculate what was your and I guess in the US called what's Energy Plus or something like that. Yeah, Energy Plus. So the same procedure. Then of course it's based on your usage. But the second method, which is like building method based on your building components, it's more reliable as well.
No,
That's
I know
why it's
the NG
so that's
Plus,
more detailed, and acceptance of the results is more inclined into direction that you should better use models, in that case like real structure, what you have there. If you use let's say aerated concrete walls, and you definitely need to add their specs, what's the lambda values of
agree,
and so
yeah.
on, so
So,
you
but,
can kind of make a simulation
yeah.
in that case.
But if you do a simulation, for example, in a system build, you're going to find out it's really hard to define what kind of airtightness that existing building has, or you have to do that kind of blow-door test. That's,
yeah, and
then you're adding a lot of cost on that project. So after a while, it's more wise to get up the energy bill, assume that you have some kind of airtightness, because you have to go to the promise that you're going to deliver. It's more important that you're sure that your promise is on a higher level than that. Recalculate existing building over and over again. That's my suggestion, because then you're spending a lot of energy in looking to the existing building, because you have to put energy in on how you promise your new skin of your new solution.
I agree with you. You can potentially, but what the point of running the blower test? It's not just to check how leaky your house, but if you do apply minus 50 Pascal or plus 50 Pascal, or pressurize positively and negatively building, you will directly see, even with naked hand, in that case, not an eye, naked hand, you can feel draft coming from cracks or from not properly installed gaskets of the doors, windows. You will be able to see the same structure. As you can see, can you imagine that same thing?
Oh, I understand.
I mean, just
good.
try giving two examples.
I know.
One
I
is
understand.
why it's blower test needed for that case, because you see the pattern of the heat going out or cold air coming in. In that case, cold air is coming in, so it's your money that you lose. Of course, the level air tightness plays 99% energy efficiency in the whole building. So it means you already have approximate number. It's a nice method. So it means if you, let's say you have 100% or let's say 100 euros that you pay for your energy bill, let's say 100, it's more than 1,000 euros. It means if you have 9%, so just calculate already, you have potentially losing that money just for that case.
Yeah.
That
No,
you
but
have
I mean on the scale, because we do that kind of projects where we do 200 houses, then we do an air tightness test.
You do?
Yeah, we do that kind of projects, complete areas. And do, really accurate measuring with point clouds, then prefabricated walls and roofs, and just make an envelope of the existing buildings. So then we do this kind of depth analysis. We do an air tightness test, we do big point clouds, we do construction tests, pooling tests. But then that's a really good solution for, let's say, 200 houses at least. 40, that's not less. The difficulty is that more private housing, because if you do this kind of private housing with this kind of investigation, you're already spending too much money instead of just buying a new window, because for one client. We also have difficulty with it, to be honest. We've been working with it to go to more photogrammetry stuff, so you don't model that much anymore, and getting out of that engineering cost and calculation, because one single house you don't have that much of.
I must confess, in Germany, at least, I experienced that thing. Did some blower test together when I was doing my research. it's quite often that single family houses will be doing the border test and research and thermal infrared imaging will be directly as a mandatory attached, so you don't have to pay additional. I don't think that's the price for the whole building complex, like a residential skyscraper. That's different story. You will not do the blower door test with simply one framing, but maybe a multi-framing door, or in some skyscrapers there will be one truck coming with a huge blower or fan, and that will be a different budget. But for single family houses, the budget that you pay for blower door service, just it's test.
I know
It will not cover you one window. It's cheap enough.
Now we work also for the German government, and they also complaining they do that
Product.
obligation that you have that energy consultants, otherwise you don't get subsidy.
Yeah.
So, but they also complaining that it's getting a lot of costs involved for just one single housing. So they're also asking the same question: can you lower down in that kind of cost making for just a house, because it's getting off of your total budget of renovation.
Yeah.
So, and I think I don't have a solution yet, but it's a really interesting one. Not only should look to how far can we get in documentation numbers, but also how can we get it faster and easier. The second question is even harder than the first one. And to make a complete IFC with all the bells and colors and beauty, I think theoretically we could build it. But is it cost beneficially for this market? Not. And that's the really difficult question. So the second question is even more important than the first one. Can we make it? Yes. Is it good solution for this market? Not. And that makes it really, really tough.
Yeah, I guess.
Yeah, the whole cost benefit juxtaposition is one that I think the whole industry keeps wrestling with.
Yeah.
You know, this
Especially for this existing buildings.
Yeah, indeed. And I think, well, I don't know what I think. Well, I do know what I think. What I think isn't necessarily right. I don't know whether it's a volume. I don't know whether it's an issue that will go away as the technology becomes more advanced and more widely adopted. There is still an aspect, I think, of modelling as seen as an on-cost rather than a route to whole life asset management and whole life cycle analysis. And I think that's part of what we're wrestling with here.
Yeah. We do a lot of in going to the tools that you can do it your own, or do it with photos or stuff like that. So getting out of that expensive equipment or person who have to go to your house. And then, you're on lower quality, but you are also on a really low cost.
I mean,
consumer, especially for a single part house, because it is not that difficult to do for high rise or complete neighborhoods. Do you do the expensive investigations with, let's say, specialists? But single family houses are the most difficult one.
But at least IFC, but if you use IFC model as a basis, you can at least for later stages, you can provide any kind of QTO information. You can provide any kind of information for banks, for in some cases, incentives, financial support fundings that they still need proof of concept or if it works, and you need to provide some documents. And of course, it's always a good chance to give some reliable information. You have IFC building, let's say, at least in that case that it was captured.
Exactly, but I think that the issue here, Mabek, is that for knowledgeable visionaries like yourself, it's really obvious this is what we should be doing. But for big corporate investors, they're not getting it yet, and that's part of the challenge that we've got as a community, is to sell that message and convince people or demonstrate people that there is a benefit. And games or demonstrations like this, I think, can be really useful if we can make it accessible to executives of, the decision makers and the. You've held a lot of people's attention. And when I say a lot of people, everybody in this room is representing a significant part of the industry. You've got airport developers here. You've got people who are interested in stations, bigger passenger interfaces, off-site modular, big residential and office buildings as well. So it's definitely captured people's interest. Lex, you're going to say something?
It was a great idea to tell this as a story, as a game, as the Richard's house is needed to do some renovation. I think it could also be a professional game for our group to do next time. Maybe
Yeah.
this for the local venue in Singapore, and then do it in one day, maybe, and then film that. Or
Yeah, it's open for everything. Great, thank you.
Well, we're at time, so I want to thank our experts. That's Jan Anders, our real experts, Jan Anders, David Ivy, and Merbeck. So well done, everybody. And,
Thank
you.
Oh, by the way, I forgot to mention we had that all numbers as well. Oh God. Yeah, Building had that number. Yeah, by the way, that's your number. Like here you are. Where was it? 25.5.